So I say, oh, I'm learning to be the light.
Here is lesson 2 of unit 4. We're working on simplifying algebraic expressions. And so again, algebraic expressions just meaning we're using both numbers and variables. And so there are 4 definitions that you need to copy down, things that we're going to be talking about and discussing as we label these algebraic expressions, because first part of this is going to be identifying what's what, and we're identifying our different terms, and is it a coefficient, is it a like term, or is it a constant? And then from there, combining like terms. So first off is what is a term? It's just the different parts of an algebraic expression that are separated by plus or minus signs. So you've seen expressions, and every time you see a plus or a minus sign, that separates the different, what we call terms. And so we'll get into specific terms here in a few minutes when we look at that. But for now, you just need to recognize the terms are separated by plus or minus signs. A coefficient, if you have not heard that term before, the coefficient is the numerical part of a term containing a variable. So if you had the term 5x, 5 is the coefficient because it sits in front of a variable. So 5x, 5 would be the coefficient because it sits in front of a variable. Like terms are terms that contain the same variables. So 5x and 11x are the same, what we would call like terms, because they both have an x. Now, if I had 5x and 10xy, that is not the same because one has a y and one has just an x. And then a constant is just a term without a variable. So 5, that's a constant. 10 is a constant. 15 is a constant. -7 is a constant. Any number, so all the integers and numbers that we've talked about so far this year are all constants. Once you add a variable, now it becomes, the number becomes the coefficient. Alright, so once you have those copied down, you're going to go through an example of how to label those and what that looks like specifically. So for instance, if I had the expression (3x minus 4x plus y minus 2. What we want to go through and do are label first the terms. We're just going to label all of the individual terms. We're going to identify the like terms. We're going to identify the coefficients. And we're going to identify the constants. So first off, looking at this, remember terms are separated by plus and minus signs. So all the terms, we have 3x is a term, -4x is a term, so that minus sign stays with it. Positive y is a term, and -2 is a term. So we have 4 different terms: 3x, -4y, or -4x, y, and -2. Now, of these 4, so now we're really just looking at these 4 different things. Of these 4, which ones are like terms? Well, these 2 are. We have 3x and -4x are like terms because they share the same variable. Y is not like terms because nothing else has y, and -2 has no variable at all, and it shares nothing with anyone. coefficients. So the coefficient of 3x is 3. Coefficient of negative 4x is negative 4. And the coefficient of y is 1. There's always an invisible 1 in front of every variable. So a variable is never just a variable. There's always a coefficient and the variable itself. And then constants would just be negative 2. Alright, I'm going to give you guys another one. And I want you to try to identify these, and then I'll go through and give you the answers. So here's another one. So go through and identify each of the individual terms, the like terms, the coefficients, and the constants. So take a moment, identify each of those. So terms, we have 4 of them. We have 9a, again negative 2a, 3b, and negative 5. Like terms, so of these 4, which ones have something in common? It would be 9a and negative 2a. Coefficients, anywhere you see a variable, there should be a coefficient with it. So we have a 9, a negative 2, and a 3. And then constants, we have a negative 5. And that's all that's to it. So you will have some examples of that. Alright, so a few other definitions we need to talk about before we can actually get to simplifying these. First one being simplest form. So simplest form is an algebraic expression with no like terms and no parentheses. Essentially, all of those things have been taken care of and simplified as far as they can go. And then if they ask you to simplify an expression, that means we're combining like terms. To get the simplest form of an expression. So make sure to have those two definitions copied down. So simplifying the expression, this is going to be more of a direction when we do these types of things. You'll see that in the directions. It'll say simplify the expressions. And so you have to know how to combine the like terms to get the simplest form. In simplest form, you have to know what it is so you can get it there. So simplest form just means there should be no like terms, no parentheses. Eventually that'll mean no exponents or anything either. Alright, so let's take a look at just some examples. Of how to simplify the expressions. So if I had 6n plus 3 plus 2n. The easiest way to do this is to identify what are your like terms. So I'm going to box in my like terms. 2n. Those two are like terms because they both have an n. So how do I combine like terms? All you do is you add the coefficients. So think about apples. If I have 6 apples and 2 apples, I have 8 apples. Well, the letter n is just an object. If I have 6 n's and 2 n's, I have 8 n's. So it's 8n, and then nothing happens with the 3 because they can't combine with anything. These are not like terms, so you cannot combine those. Let's look at another one. If I have 3x minus 5 minus 8x plus 6. Now again, the terms carry the sign in front of them. So 3x has the same term, or is like terms, with a minus 8x. So this minus goes with the 8. So 3x and minus 8 is going to be minus 5x. Now I also have two constants. I have a minus 5 and a positive 6. So I combine those two, negative 5 plus 6, and I get a positive 1. And that's my final answer. Alright, now I'm kind of working backwards here because I'm trying to squeeze it in. So I'm going to put C and D. It's all part of the same example. But I want you guys to do these. So we have 8e. Well, actually, this one we're going to do together because it's using our last section of the distributive property before we can rewrite anything. So first off, we have to use the distributive property to re-simplify this and rewrite this before we can simplify to our simplest form. So 8e has to get rewritten. Now this minus sign, remember, it distributes with, so ignore this. We have minus 4 times 2f. So you can kind of view that as minus 4 times 2f. And then you have minus 4 times 5e. So we multiply. It's 8e minus 8f minus 20e. Now identify like terms. So we had negative 4 times 2f gives me negative 8f. Negative 4 times 5e gave me negative 20e. Combine like terms, so I have 8e and negative 20e gives me negative 12e and then minus 8f. So that's one of the more complex examples that we're going to have. So we'll get there and we'll continue to work on that. I want you to see one of those just so you are aware of kind of what's coming here. Alright, so go ahead and work on these two. So we have 4q plus 12p plus p. And then we have 2x minus 5 minus 4x plus 8. So go ahead and take a minute, complete those two examples, and then I'll put the answers up on the board. Again, identifying our like terms, we have a positive 12p and a positive p. Remember, there's an invisible 1 here, so you can view that as 1p. So the 4q stays the same, nothing gets added. 12 plus 1 gives me 13p. Identify like terms down here in the next one. 2x, negative 4x, negative 5, and positive 8. So my two squares, 2x, negative 4x gives me a negative 2x. Negative 5 plus 8 gives me a positive 3. That's all the further that we can take that one. And that is how you simplify algebraic expressions.